Hello everyone, welcome back. Today let's solve the 25th top code entry question from 48 top code entry questions curated by LeetCode. We'll solve this problem using Python. This problem is on linked list, detecting a cycle in the linked list. So if you see this example, this is the linked list where the last node cycle. How do I say cycle? So basically, last node is connected to one of the nodes which are before the last node, right? So here, if you see here, last node is connected to the second or the first position. If the position starts with 0, so this is connected to the second node or the first position node. So this node is connected back to this node. So basically, there is a cycle here, right? There is a cycle here. The address of this is connected to this node. That is a cycle here. So that's what it says. We have to detect whether there is a cycle in the given linked list or not. Here, if you see this one, the 2 is connected to 1, so there is a cycle here. So that's what they are. The tail is connected to the zeroth zeroth node. So which is the first node, right? If you start the index with 0, and here there is only one node, so there is no cycle. So we have to return false. We'll solve this problem. There are the best algorithm to solve this problem is something like a Floyd's tortoise and hare algorithm. So here, I'm sure you must have heard the story of tortoise and hare, where tortoise goes slow and hare goes faster, right? So imagine we have to go in a similar way, right? So imagine we have two pointers similar to tortoise and hare. So the fast pointer, the spelling is wrong. So this fast pointer, FA. So what we'll do is, how do you solve this problem? You use something like a slow pointer and the fast pointer. Imagine this is a circle, right? When fast pointer, obviously he runs faster, right? He runs faster. Imagine he's running across this circle. He runs very fast. And then slow pointer is also there. Slow pointer also runs, but he runs slowly. He runs slowly. He runs slow pointer runs slowly across the circles. So obviously, when like imagine there will be a point where fast pointer is also moving, and slow pointer is also moving. There will be situation where both of them meet, right? Fast pointer will certainly reach to the fast pointer is here. He continuously moves, but slow pointer also moves. Maybe they reach to a stage where both of them reached at this location, where both of them reach to a same node. Fast pointer somehow, if they are continuously moving, if continuously running for, let's say, 2-3 rounds, obviously the fast pointer can come to slow pointer before it finishes even one circle also, right? So this can be possible. This we use the same analogy. So what we'll do is, we'll create two pointers. One pointer is called fast pointer, and the second pointer is called slow pointer. So wherever there is a situation where fast pointer meets or slow pointer and pointer becomes same, right? Whenever they reach to a node where slow pointers and fast pointer becomes at the same location, then we assume that there is a circle in the linked list. That's assumption. We solve using this problem only. So what we'll have is, I'll use something like a slow pointer. uh, Slow pointer. I'll For the sake of simplicity, I'll simply say slow pointer, and this is fast pointer. I'll put this in a head. I'll pass the head of this linked list for these two. Then what I'll do is, basically, while I'll take, both of them are not null, both of them not reach to a null, right? So uh, fast fast, and and I'll basically fast and fast of, it should not happen that fast is also not null. First goes first, right? Fast and fast dot fast pointer dot next, both are not null. So when I'm if it is null, obviously when we have a null, right? So we don't go next, right? So because we move fast pointer two times, that's the reason we are checking here. Fast is not null, and then fast pointers also not null. Both of them are not null. Then what we'll do is, will simply, slow pointer will move slow pointer to only one step ahead, and will move fast pointer 2 steps ahead. Next and next. So basically, it moves faster. So there will be situation when where fast pointer is equal to slow pointer, or you can say slow pointer is equal to fast pointer. If that situation arises, right, well, while moving, so first of all we will check. The reason why we are checking two times is basically the next is to make sure that we are moving towards that. So that's the reason we are checking this. So here fast, we are basically moving fast, slower one step and faster two steps in each iteration. In this, anywhere, if they are equal, simply all you have to do is we simply have to return true. Else, we come out of the loop, everything is fine. I mean, we haven't reached to that stage. Everything is like, if fast is nowhere equal to slow, then by default it is a false. That's what it is. So it's basically the same diagram which I showed. The fast pointer moves two steps, slow pointer moves one step. There will be a situation if there is a circle. There is a circle. If there is no circle, if it is the end of the list, so it will not go within that condition. If there is a circle, so there will be a situation where both of them collide at one node. If they both of them, by this algorithm, if you can read about more about this algorithm, by this algorithm there will be a situation where faster will collide with the slower at one node. So which means there is a circle here. So circle not necessarily, in some of the examples. Okay, it got accepted. Let me submit, run it. So not here, if you see, this circle is within this, and it not necessarily the first node is connecting back to the last node is connecting back to the first node. So here, we just have to detect the circle. So there will be situation where fast will point to the slow, and that's how we use this algorithm. I hope you understood. And then please try to debug this. I mean, in many of my PS examples, I've put the debugger and explain that. In many of the previous examples, please try to create a link list, your own link list, using these kind of functionalities, and then try to debug, and then try to put a breakpoint and see how fast pointer is going, how slow pointer is going, what's the address of the last node, how it is pointing back to the previous nodes. So to check the circles, so please put the debugger and let me know in the comment section. All right, that's all guys, for this video. See you in the next video. Thank you for watching.